Good morning, all. I think we're 4 minutes past now, and we've got a good attendance on the call, so we'll make a start. So just to start off with, my name's Chris Packwood. I am our workshop and calibration manager at Cadent, and I'm also sit on the Midlands branch Pipeline Industries Guild Committee, and then also the Pipeline Industries Guild Professional Development Network Chair for the Midlands. So really pleased to welcome Neil onto the call today. Neil is from STATS Group and is going to talk to us about the high integrity temporary isolations for pressurized onshore gas pipelines. Neil and STATS have been doing some really exciting pieces of work within the industry, both the UK and elsewhere. I'm really pleased to have you on today, Neil. If you could remain on mute for the duration of the call, and also with your cameras off. If you have questions whilst Neil is presenting, please do put them in the chat, and then there'll be a time for Q&A at the end, where we will sort of call out the questions from the chat, and also provide opportunity to come off mute and ask Neil yourselves. So without further ado, I think that's it from me for now, and I'll hand over to Neil for the presentation.
Thanks very much, Chris, and thanks to Kate and and to the Guild for inviting me along again to present. I think it's fair to say I'm probably a PIG webinar veteran now. I've done a few presentations over the last few years. They've all been quite technical. Today's presentation is really about 4 case histories, projects that we've done onshore in the UK over the last year, and they're all unique in their own way. So yeah, I'm just delighted. It's an exciting time for us at STATS, really exciting time. So yeah, I hope you enjoy the presentation, and if you have any questions technically at the end that I've not covered, then I'd be delighted to answer those. For those of you who perhaps aren't familiar with STATS Group, we are market leaders in the supply of pipeline isolation, hot tapping and plugging services, and we're servicing the global oil and gas industry, some work in petrochemical plants as well. Our BISEP and Remote Tecno Plug are our flagship tools. They're the bread and butter of the company, and we're proud of the fact that these tools are DNV type approved. They provide a leak tight double block and bleed isolation, and they're enabling the safe and efficient maintenance and repair of onshore pipelines, but also topsides, that is offshore platforms, and subsea pipelines. The BISEP is an alternative to the Stoppel, seen subsea version left, onshore version right, and the Technoplug is an isolation PIG. So what sort of applications are there for these temporary isolation tools? Well, from top to bottom, most commonly we are using these tools to isolate valves that are perhaps leaking or damaged or passing, and other features as well in the pipeline, like IJs. Next would be removal and replacement of a pipeline section or dead leg, followed by new pipeline infrastructure development, so tying in pipelines to existing lines or retrospectively fitting pigging facilities, for example. And then last but by no means least, EPRS, emergency pipeline repair systems, which just simply means having a bunch of tools of the correct sizes, pre-qualified, ready for use in the event of an emergency. And we have contracts like that globally for operators for subsea applications, and in some cases also some tools in stock for onshore emergencies too. So there's 4 projects to tell you about that have all happened within the last year for National Gas, GNI, Cadent and Mutual Energy. And here I've kind of put them under the categories that they fall into, just to give you an appreciation of the sort of wide range of scopes that we get involved with. Firstly, a quick overview about our Technoplug technology. The Technoplug comes in two forms. It's remotely controlled. The top picture and the bottom picture shows a tethered option for the tool. It's a piggable double block and bleed mechanical isolation plug. It has a set of locks on the tool which expand and grip into the pipe, providing mechanical restraint, and then a set of dual elastomer seals which provide the double block and monitor. The tools come from 3" to 56" and 10" for the remote control tool and app. And as standard, they're good for up to 230 bar when we've done some jobs up to 600 bar previously as well. The tools are DNV type approved and they're hydraulically actuated. And then they have another hydraulic fail-safe feature where the differential pressure acting across the plugs self-energizes the plugs. So if you have, say, 100 bar in the pipe and you have 0 bar behind the tool back towards the work site, that differential pressure of 100 bar keeps the tool locked in position in the event of a failure of the hydraulics. The tether plugs, particularly seen bottom right, are very compact, so ideal for positioning between a pig trap isolation valve and a supply tee, a branch. So they can isolate the pig trap or the valve while the pipeline remains flowing and at pressure for the repair work scope. I'm really pleased to say that this year, for the first time, STATS and National Gas successfully completed the first Remote Tecno Plug isolation on the national transmission system. It was for an IJ replacement and it was in June this year, around 30 miles south of Aberdeen. Traditionally, these operations were these like IJ replacements or pig trap isolation valve changeouts were done by National Gas using recompression units. And these units suck the gas out of the pipeline to be worked on and re-inject it into another part of the network. And those recompression units currently can take the pipeline down to 7 bar, at which point the remaining gas is vented to atmosphere. But when you have a 48" pipeline for 58 kilometres, 7 bar is an awful lot to vent. And on that basis, for environmental reasons, National Gas wouldn't do it. So the Remote Tecno Plug really enabled this critical work scope to happen. The plug is launched using gas, or it was in this case. You can also use nitrogen, and offshore sometimes we use MEG and diesel, for example, has been used too. It was pigged around 300 meters into the line, set and tested, by which time National Gas had vented and purged the isolated pipeline. I think it's an important point to mention as well that the RTP, the plug, provides a gas-safe barrier, so no additional equipment is required. Once the pipeline was vented and purged, the IJ was cut out and a new IJ was welded into place. So yeah, the first time the plug was used onshore instead of recompression units, which would have been the alternative method. It provided a 100% leak-tight isolation for 21 days, isolated against roughly 55 bar for 58 kilometres to the nearest isolation. So a lot of time is saved as well. You know, offshore particularly, the alternative is not recompression units. The alternative is just venting the pipeline. I say venting, it's flared, the gas being converted to CO2 there. So sometimes the tool is used to save money. Sometimes it's used to save time, and of course time is money. And sometimes it's used for its environmental benefits. So a fantastic piece of technology. National Gas saved around 125k by using the plug, and certainly more importantly, the environmental impact, the environmental saving was that by using the plug, we It was the equivalent of switching off over 1,700 gas boilers in the UK for a year, or removing 100 small cars from the road's carbon equivalent. So not insignificant by any means. And the plug technology is now approved for use on the NTS, with a couple of 2 or 3 projects already identified. Moving on from the plug technology to our BISEP tool. The BISEP stands for branch installed self-energized plug, and it's an alternative to the stopple. Basically, you hot tap the pipeline, that is, drill into a flowing and or pressurized pipeline, and then we hydraulically deploy the BISEP into the line. The BISEP head, is hydraulically rotated during deployment and then hydraulically contracted, causing dual rubber seals to energize against the ID. We then have an annulus void between the seals, which is monitored throughout the duration of the isolation, and if the primary seal was to leak, then the gas couldn't be vented from the annulus to a safe location. The tool allows flow to be maintained through a temporary bypass, coming along the pipe, up through the BISEP and along here, usually off to another BISEP, which would be out of the picture to the right, and then down and off into the pipeline. The tool is also fail-safe, like the Tecno Plug. It's self-energized by the pipeline differential pressure once the isolated section has been depressurized. DS means dual set. The DS BISEP has an additional hydraulic locking feature versus our standard BISEP, which I'll tell you about in a bit. In situations where the DP is very low, for example in LP or MP pipeline systems, the additional locking feature provides additional safety when the tool is not self-energized, if there's not enough DP in the pipe. I'm now going to show you a video. It's a few minutes long, of a project we just completed for Mutual Energy in Northern Ireland. Let me know if there's any issues with the sound.
Mutual Energy owns, operates and maintains natural gas pipelines across Northern Ireland. Its latest large-scale business customer, Kilroot Power Station, was facing closure due to environmental regulations on burning coal. Just under 3 kilometres away, Mutual Energy needed to tap into their pipeline to get the power station connected. But they couldn't stop gas flowing to homes and businesses.
We have to do that connection while supplying those customers. So we're doing it live, as we would call it. So to do that at a very early stage, we wanted to use what would be the best technology available.
Mutual turned to the STATS Group.
STATS are a leading industry provider of leak-type pipeline isolation and intervention tools.
First, the exposed Belfast gas pipeline was cut into using a special seal drill system, which breaks through the pipe while the gas still flows. Then the BISEP plugging and diversion tools were mounted.
Within this launcher housing that you see, the green part, there is a plugging head with 2 seals, 2 elastomeric seals, which we deploy into the line hydraulically, and this stops the flow, allowing us to provide a proven leak-type double barrier. The flow of the pipeline is actually routed through the green housing that you see, the green launcher, ensuring that the gas supply remains alive to its required users.
Gas was then directed into a bypass pipe to allow the connection works to get underway.
As a company, we're delighted with how the job has went so far. Both tools are in, have been sitting here now for a number of weeks, isolating leak-tight, rock solid, with not a single ounce of gas moving past. So they're performing exactly as they should do.
It's the first time in UK onshore gas transmission that they've used this technology in this way. And it does bring considerable benefits in terms of the size of the excavation, the number of interactions with their pipeline, and all of these things increase the risk when you're working on an existing pipeline. With the STATS BISEP DS, we've been able to reduce those risks. We're delighted they've got to where we are at this point.
This technology has a long-standing track record in traditional oil and gas industries, working for major operators, tier 1 contractors, etc. However, we have also deployed the same technology in liquid CO2, being the first company in the world, the only company in the world, to have hot tapped and isolated high pressure liquid CO2. As we look forward to the energy transition, which is going to involve hydrogen as part of this as well, and also into carbon capture, we're very well placed to support this. As I say, having been the only company to have isolated high pressure liquid CO2, but we are also working within hydrogen blend and full 100% hydrogen systems. So we believe we're very well positioned to support the network as it moves through the energy transition.
The connection to the Belfast gas transmission pipeline is now substantially completed and will be ready for commissioning later this year.
Yeah, so I think that I wanted to show you that video because yeah, it's always good to hear from the clients, to be honest. I could tell you something was great, but when a client says it's good, it carries perhaps a little more weight. So looking again at this project, the Kilroot power station was facing closure to environmental regulations, and it needs to be converted from coal to gas. The power station needed to be tied in to a very important transmission pipeline, the BGTP, the Belfast Gas Transmission Pipeline, which was about 3 kilometres away from the power station. So you can see the power station in the background here, the pipeline route, and then this is the tie-in location in the foreground. So this had to be done live. We couldn't afford to, the client couldn't afford to shut the pipeline down while the tie-in was performed. So we performed the hot tapping and the line stopping, and it was the first use of the BISEP in onshore UK gas transmission or distribution. Completed in December last year, the BISEP provided a fail-safe leak-tight double block and bleed isolation, which meant less gas discharge to atmosphere versus traditional technology. The DS BISEP method as well only requires 4 pipeline fittings. So in the image in the bottom left, you would have 2 to 24-inch welded T's there, and not shown, you would have 2 2-inch welder flanges for vent and purge, versus the traditional method, which typically uses 10 fittings, which made the overall excavation much smaller and reduced risk on the project. This pipe was also on an incline of 4.5 degrees, which would have been problematic, if not impossible, with the traditional tooling. So again, the BISEP here enabled a project that would have been tricky, or at least, if not impossible, certainly tricky to undertake otherwise. 2 24-inch DS BISEPs provided that isolation for 2 months, isolating 60 bar gas, while the new valve manifold was tied in and pipeline connected towards Kilroot. So a project of firsts, because this was also the first project that we used our external pipe end plug technology, seen in the third picture there, EPEPs, and they're used here as an alternative to weld caps, essentially an additional safety measure, not leaving a pipeline open-ended overnight or unsupervised. The BISEP, like I've said many times, probably too many, was 100% leak tight, so the EPEP's not there to encourage gas up the 2-inch vent that you can see. It's there just as a precautionary measure, instead of a weld cap. You get an appreciation from pictures 1 and 2 of how close the BISEP plugging head is from the open-ended cut pipe. And on the right-hand side, the welding, the tie-in being done, again, very close to the BISEP isolation, absolutely standard, typical for us at STATS. Next, we did the first project for Cadent this year. We were contracted by United Living to provide 4 12-inch DS BISEPs to support a pipeline diversion on the St Leonards to Hickson pipeline. And that was done as part of the HS2 railway project. So pipeline diversions are required where there's new infrastructure going in or a new development, and the pipe classification, that is the wall thickness or condition of the pipeline, is not suitable for the infrastructure that's about to go over it, or it's too close in terms of building proximity to the pipeline. So they either reuse the same pipeline spec and just move it away from the thing going in, the development or the railway. But if you can't avoid the pipeline route crossing the new infrastructure or being built close to the new complex or whatever it is, then they just increase the spec of the pipeline, increase the wall thickness and grade of the pipeline. So in this scenario, these pipeline diversions, they're usually really long sections of pipeline, which is why you don't just use 2 biceps very far away from each other, because then you would need to commission a very long temporary bypass. Whereas when you use 4, you can isolate 2 short sections of pipeline, commission 2 short temporary bypass lines, and it's a very efficient method of doing this kind of work. So this was the first bicep deployment for Cadent, but it was also the first bicep deployment through grouted tees, also known as epoxy tees. I guess now is a good time to say that all of the tooling that we use is compatible with industry standard tees and interfaces, for example, welded tees. But we do deploy the biceps through clamps as well, especially useful offshore where welding's not permitted, or subsea where welding is uneconomical and also much riskier than using a clamp. This pipeline was also on a slope, which meant that traditional tooling could not be used. Stopples could not be used on this project, I was told. And so the biceps provided a leak-tight double block and bleed here on this 19-bar pipeline for 30 days. And finally, the 4th project I wanted to tell you about today was the first bicep deployment for Gas Networks Ireland at their Caherlag above ground installation near Cork in July this summer. 2 4-inch biceps were used. They were deployed either side of a leaking valve indicated in orange or yellow. Depending on your eyes, I think it looks orange to me. And the biceps were deployed at the red circled locations on a horizontal section of pipe below ground, which meant that the client didn't need to use stopples, which couldn't have been fitted on these sections. The stopples would have had to have gone in on the main line running perpendicular to these 2 short sections. And so instead of using 2 4-inch fittings and biceps, the client would have needed 10 12-inch fittings and to commission a bypass. Excavation size, fittings, risk, everything would have been drastically increased with the alternative. So up until telling you about the G&I project, you've seen the DS bicep, which has an integrated bypass. On this project, we didn't need a bypass. We were just isolating either side of the valve. We weren't interrupting flow in the main line. And so the tool for the job is our standard bicep, which the head goes in the opposite direction to the DS bicep, and that allows you to vent and purge through the bicep launchers. This solution greatly reduced the risk and the cost to the alternative, and of course the environmental benefits of the bicep are evident on every project, providing a 100% leak-tight isolation. So at that point, I would say thank you very much for listening, and if you have any questions about any of the projects or anything that wasn't clear, then I'd be more than happy to answer those.
Hi, Neil. Thank you very much for that. Chris here. I've just checking through the chat. We've got a question from Kevin Bird. Regarding the biceps double block and bleed, presumably this required a second small hot tap of the existing line between the two seals to then bleed that section.
Thanks for your question, Kevin. It's a very good question. So the bicep, you'll see this image here, there's a small hole on this annulus ring. And when the bicep head is contracted and these two seals energize against the ID, we have 4 of these little 1/4 inch holes which commingle into a 1/4 inch instrument line, which isn't shown in this image. And it coils and it runs through the center of the tool and then up through a sealing housing off to our control panel outside the pipe. So once the head is energized, we vent off the isolated annulus, and that's crucial as part of the seal testing process. So each of these seals is actually tested to equal to or greater than the pipeline pressure. And then we have a hold period as well, just to prove that there's no pressure rise in the annulus before signing an isolation certificate to say that it's safe to cut the pipe and weld. So we access the annulus through this port, not an additional hot tap on the line.
Thank you. And one question from Matt Turner. Would this technology potentially be suitable for thermoplastic composite pipe rather than steel?
At the moment, no. Our inventor in the Middle East is working on some developments of the technology for use in other materials. I think, yeah, PE pipe being one of them. But at the moment, the standard tooling is all designed around steel pipes.
Thank you, Neil. Thank you, Matt. Would anybody got any questions they'd like to put their hand up and come off mute, or pop it in the chat? Yeah, Phil, we've got a question.
Yeah, hi Neil. Hi Chris. Thanks for that. I'm just reflecting on it, thinking it's very difficult to see why you'd ever use the old technology again. You know, why we'd go to 4 T's and all the various vents, the 10 fittings you spoke about. What is that right? You know, in terms of this solution, is it just that this should now be the standard?
In my humble opinion, yes. But of course, the bicep is an engineered. It's more engineered than the alternative, but we do respond very quickly to inquiries for emergency pipeline repairs. So yeah, I mean, there's dressing kits for these tools, so there's like a body, a head body, and then there's dressing kits and seals required depending on the pipe ID. And we don't keep stock of every single pipe variation. So what we tend to do is just have what we need for the geographical location. Like the pipes are all of a similar spec here, for example, in the UK. So we will just make sure that we have everything we need. The stopples are less, I think, probably less sensitive, and there's a huge stock of them in the UK. So yeah, if something weird and wonderful came up, because our seals are very high integrity, we don't have a stock of every single configuration at the moment, you know, then reaction time might be slower. But these projects that we're working on are engineered projects. You're getting 3 months to a year's worth of notice. And yeah, it's again, just additionally to that, the tool was developed after the Tecno Plug to provide the same level of safety in a non-piggable pipeline, and it was sold for years and years on its safety benefits. And onshore in gas, the environmental benefits, I would say, are equally important now versus the safety benefits. But with the advent of hydrogen, and we have proven that the bicep works in 100% hydrogen recently, the case for safety will become again more prevalent than like it was initially when the tool was developed.
Thanks, Neil. Yeah, very impressive.
We've just got one more question in the chat, Neil. Kevin Bird. You referred to energizing the seals. Apologies if I missed it, but is this an active internal pressurization within the head to press the seals against the ID, or is it based on accurate sizing of seals for the ID and pressure associated with the head moving into place?
It's kind of both, actually. So the seals are sized for the pipe ID. For nominal pipe sizes, 8-inch, 10-inch, 12-inch, we'd have different types of seals for different nominal IDs. Well, the same nominal ID, but with different wall thicknesses, we would have different seal sets. There's a hydraulic cylinder inside here, and when it's energized, the spherical head on the left moves to the right-hand side, and that compresses the seals and causes them to expand radially into the ID of the pipe. So they have to jump, but it's not a significant jump. And once you unset the tool, the seals will relax on their own to an extent due to molded springs, which store kinetic energy. Does that answer the question? I think it does.
Yes, thanks, Neil. Appreciate that.
We've got one more question in the chat from Neo Modis. He's from South Africa. Does the tool sweep off cutting shavings off the pipe floor? What about debris on pipe internal diameter surfaces?
So great question, Neo. Thanks for joining as well. The bicep head does sweep away the swarf. When it's deployed into the pipeline, it sweeps the swarf out of the way. And in this case here, you can see that the swarf has also made its way somewhat away from the head, and probably due to the increased velocity around the bicep head or something, like pushing it a little bit down the line. The pipe has to be ideally smooth and clean, but we have sealed in some pretty horrendous gunky stuff. I can't even tell you what it was. It was probably a mixture of black powder and oil and all sorts. I've got a picture I'll send you, Neo, after, which of a bicep in a really dirty pipeline. So ideally clean and smooth and everything, but that's not to say we couldn't deploy and try and get a seal in something of a worse condition.
Okay, thank you, Neil. Any more questions from the? There's no more in the chat as yet. Feel free to pop one in or put your hand up. And while we're waiting, I've got a quick one, Neil. On the when you pressurize the seal, you achieve the seal, vent the cavity. What sort of proving times or monitoring times do you have on the annulus before you can say, yeah, thumbs up, we can do the work we need to do on the isolated section?
Yeah, we would usually just do an hour maximum on each seal at 100% of DP, and then we would have a hold period. Onshore, we might do that overnight just for extra confidence, because usually that's how it pans out. You've come to the end of a shift, you might as well just leave the bicep there overnight before you've broken containment. So it varies depending on the client's requirements and on the operational scheduling, but certainly an hour on each seal, and then a hold period of usually a minimum of 4 hours. And again, it's usually longer than that because by the time the 4 hours is up, you're into the evening, and then you just pick it up in the morning and yeah, confirm that it's all good.
Cool. No, brilliant. Thank you. Final call for questions. Anybody in the chat or hand up?
And obviously, if anyone thinks of something, or has got a more detailed question they can't quite articulate at the moment or whatever, then I'd be delighted to hear from you. So just drop me an email or contact Chris or get me on LinkedIn or however you prefer. I'm more than happy to tell you more about the tools, and we've got some really exciting projects as well, like that just haven't happened yet, that are in the making. So I fully expect that in a year from now I hope I'll be back. Hopefully you'll have me back, Chris and Kate. But I'll come back and I'll tell you about 2 or 3 more things that we've done that were different again in their own right.
Yeah, brilliant. Thank you very much, Neil. Well, we've not had any more questions in the chat or hands up. So we'll say thank you very much, Neil, for that really engaging presentation. I hope everybody's taken as much from it as I have. And we'll close the call there. So thank you all and enjoy the rest of your day.
Thanks, everyone. Cheers, Chris. Thanks, Kate.
Thanks. Bye-bye.
Bye.
Thanks.